Yeah. Hello. Woot, woot. See if this is actually on. See if this is actually on. Yeah, while I'm finagling with this, I'll just say a quick comment. I want to thank Charlie Miller and his son. I think it was 2 years ago. 2 years ago, they helped me. Well, they helped me get started on what is now Twitch. So uh, I remembered Charlie's son. I mean, it ended up being a debacle, but I didn't know what Twitch was. I honestly didn't know what this Twitch thing was. I thought this was all a joke, and little did I know, after watching their stream, um, they paved road for where I am today and offering you a Twitch stream. So I want to give a shout out to Charlie Miller. I think they still have a handle on Twitch called Dingus Duo. Hello, default user. Hello, hello, hello. Can you hear? Okay. So it's another Thursday. So this course is begs the usual sound as the usual. What we got? 1 minute left. Sound check. Check check. Sound good? Audio good? Video good? We good? Yeah. All right. Hello. Sound check. Sounds good. Hello, Mellow Dots. Hello. Hello. I have no idea what. I need to take some time to really brush up on my Twitch game and understanding every little piece in the world. Such as what is this gift of something that I'm seeing right now on my other screen? Yeah. Hello, Mellow Dot. Hello, CG underscore Happy Mac. Hello. Hello. Yeah, one of my favorite times of the week is offering these Twitch streams. Really enjoy this. Um, I feel one of the things is I would just say a comment now before we begin. I'm quite curious because now school is back in session as in person. So I think we may have some camps now. It's like now it's not like the same as before where there was only one option, in person. Now you have things that are in person, online, and people have their own opinions and their sides on which they like better. Anyway, it is now 4:30 Eastern Time. Hello, everyone. I'm Ming Jia. I'm Associate Teaching Professor at Tufts University. This is the Thursday session, Introduction to Security. So again, I love doing these sessions on Thursdays on Twitch, especially on Twitch. Definitely not Zoom. But one of the things is just a friendly reminder why I offer these sessions on Twitch is um, it's the accessibility of education. That's number one. And this is not Zoom. Twitch is a fun and engaging platform. So one of the reasons why I offer these is, well, offer education. The other thing is, I also know that there is a dire need for cybersecurity education, and I can't tell you how many times people actually reach out to me and say, "I want to get started in cybersecurity. I have nowhere to be. I'll have no idea where to begin." And this is why I offer these training sessions for on Thursdays uh, for the next so many weeks. So we already did one session last week, which was on packets, uh, understanding, and network traffic, Wireshark, PCAPs. We did that last week. We're going to use some of that content that we learned last Thursday today. We're going to see PCAPs and Wireshark perhaps again today. Today's topic is absolutely one of my favorites, and it is an important skill to have when you're doing cybersecurity. Whether you're doing offense, defense, doesn't matter. And the topic is reconnaissance. Reconnaissance. Um, reconnaissance is one of those military words that you may hear all the time, and there's a lot of terminology in the military space that is used in cybersecurity. And also, there's a lot of models that are actually used from the military that translated over to cybersecurity. I mean, this is debatable, but it's definitely part of literature. And the whole idea of reconnaissance is an important part of both military literature and also with cybersecurity literature. Hello, Freedom Fighter. Hello, that guy 4348. Hello, hello. So I want to give you a little bit of a high level overview, some background information. And what is this thing called reconnaissance? Now, in cybersecurity, there is this well-known model called the cyber kill chain. Now, I'll just post a link on the chat on on Twitch. The cyber kill chain is a model that is referenced all the time. And what it is, and it was created by Lockheed Martin, and I'll just blow up the font. It's developed by Lockheed. The cyber kill chain framework is a part of intelligence-driven defense model for identification and prevention of cyber intrusion activity. So this model identifies what the adversaries must complete in order to achieve their objective. So what the cyber kill chain is, if you are an attacker, this is a process. If you are trying to attack a system, okay, and you want to gain access and to be successful, this is the process that you would follow. You will follow this model, and there are 7 steps in this cyber kill chain. 7 steps in this process, steps in this cyber kill chain. Starting with number 1. Number 1 is reconnaissance. At the very top is harvesting conference information, email address, etc. To make a long story short, what reconnaissance is, 2 words: information gathering. Gather as much information that you can about a target. This can be either, now don't be mistaken, this can be both low tech or high tech. Low tech means include things like social engineering and dumpster diving. High tech include things like Google, using search engines, and there are a number of cybersecurity, a number of tools to help you get information about a particular target. Step number 2 is weaponization, coupling exploit with backdoor into deliverable payload. 3 is the delivering weaponized bundle to the victim by email, web, USB, etc. Exploitation is number 4. Exploit a vulnerability to execute code on a victim's system. Installation, installing malware on an asset, is number 5. Command and control, command channel for remote manipulation of victim. And the last step, number 7, action on objective, which is like hands-on keyboard access, and computers accomplish their original goal. Cyber kill chain number 1, the number 1 process before you go before you go start attacking system or anything. Look, you want to gather as much information about a target or an adversary or an enemy, or get as much information as possible. Get as much information as possible. Reconnaissance is one of those words that is used all the time, not only in military but in cybersecurity. Okay, so what we're going to do today is let's transition over to what we're going to look into today. And we're going to do a lot of hands-on exercises. And we're going to use a real target. This is a target that I created. And the target is, I'm going to pull up a terminal. And the target is going to be at this IP address, 35.226.223.155. That is the target. So the target, I'm going to put it in the chat, is 35.226.223. You don't need a VM for this. No VM necessary. dot 155. Okay, so just replace the dot with the actual, well, period. Okay, or you can do. I'm not gonna type. I'm not gonna type the whole thing out. I don't want you to. Well, let's not jump the gun. So yeah, I'm using light. I'm using black and white because of readability purposes. Make it readable. Make sure. I mean, if you do black background on green text, I'm not so sure if it actually will convey well sometimes. But black and white works. So this is our target. Okay. All right. So interesting that I-10 field. Ping successful from Canada. All right. All right. All right. So now we want to gather as much information. Imagine if this is our adversary or this is going to be a target. We want to gather as much information about this target at 35.226.223.155. Okay, we want to gather as much information as possible. The first thing is, a very logical tool to use is, okay, is this target actually up? Is this available to the world? That's the first question you want to ask. It's a simple question: is this target um, on the internet? Is it up? Is it running? And the way that you would do that is, of course, I-10 field that said ping successful from Canada. So what is ping? So clear. I'm going to clear the screen. I'm going to do a man page for a tool called ping. So ping, what it does is sends an ICMP echo request packet to a network host. So in technical detail, and that's the technical details, but in lay term, what ping does is a diagnostic tool to, is to see if a computer will respond to, to respond to you on the network. So the idea of ping, where it comes from, signal from submarines. So think of submarines. If you want to see if there are objects nearby, you'll use sonars. So the idea is submarine will send out a signal, say ping, and if there's no response, you're not going to get a response. But if it does hit, if that ping signal hits an object, you'll hear a pong back. Okay, the same idea is how ping works on a technical level. So how ping works is you send a very simple ICMP echo request and hope that you get a reply of some sort. So, okay. So it's a very simple protocol, usually used for diagnostic purposes. So I'm going to type ping 35.226.223.155. So that is, I'm going to type on my command line, ping 35.226.223.155. And lo and behold, I got 64 bytes from the target. Okay, this is showing, okay, if you see this screen, that 64 bytes from yada yada yada, time to live, time to sec, that means that the target is responding. Pong, it's up and alive, it's up, it's alive, it's running on the internet somewhere. Can the ping be traced back to the sender? Will the target know when they have been pinged? The answer is absolutely. Great question. Can a ping be traced back to the sender? And the answer is absolutely it can be traced back to the sender. Will the target know that they have been pinged? Yeah. Yeah, absolutely. And how you can do that is, let me see. If you can, and so what happens is, let's say if the target is running Wireshark, and it's actually trying to capture all the information back, they can see like who's using ping against them. Okay, so ping can be traced back to the sender with caveats. Okay, will the target know they have been pinged? The answer is yes, of course. If they have, you can see it, if the target is running Wireshark and is capturing all the packets, they'll see the protocol. I want to do it. Okay, so hold on. Let me run Wireshark on. I can run Wireshark on as an attacker. So I'm gonna start. I'm gonna monitor, but I am just gonna say I'm gonna signal. I'm gonna say ICMP. I'm gonna filter out all the packets, so I'm not seeing like a whole slew of different things. I'm just seeing ICMP. But I'm gonna run ping again. Watch what happens. Watch what happens when I type ping. And you can see the source going to the destination, and then of course I got an echo. I got a request. I got a reply from back from the target. I got a request from the target. I make a request to the target. I get a reply back from the target. So if the target is recording packets and recording like everything, yeah, they'll definitely see it. Now, can a ping be traced back to the sender? Well, yes and no. Yes, in this case, if you're not using like VPN, if you're not using like virtual private networks or anything, yeah, it can be traced back. The problem is, as we will see next week, it is also extremely easy to abuse ping and to spoof packets. So yes, with a huge asterisk. Okay. Now, is ping a service or an essential part of the network stack? It is okay. That is another legendary. That's a legendary question because it's a really good one. Ping is actually an essential part of a network's huge part. If you, it's built into every single system. Huge, really, really, really. Ping is an extremely, extremely important part of the network stack. In fact, let me pull out the details about what ping is. Every operating system has ping actually built in. If you have a Mac OS, if you have a Mac system, if you're on a Mac, you have something. Oh, they don't have the network. If you have a Mac, ping is built into what network utilities. I'm going to type ping. Now, there's an important question to see, an important thing I need to mention, especially because CG_Happy Mac actually brought this up. Ping is an essential network utility, part of network stat, but it only is on layer 3 of the OSI model. It uses Internet Protocol only, so it only does source and destination. It is available, and here it is. It's virtually available on all operating systems that have networking capability, especially including most embedded networking administration software. Okay? So is there no way to hide and be invisible to pings? Okay. God, that is another legendary question. I want to get back to the who is. I want to go back to the who is question later on. So here is a very trick question. It's a very important thing. Ping is on layer 3 of the OSI model, the Internet Protocol, not layer 4. Okay? The idea of ping only uses source and destination address and maybe a couple few other things. So here is how an ICMP, also known as ICMP packet, looks like, also known as ping. Source address, destination address, that's it. Maybe a little bit of a payload. There's no concept of port numbers and data. Okay? Ping does not have anything to do with layer 4, 5, 6, or 7. Layer 3 only. Okay? Now, Angel Peach 424, that's even a great question. So there's no way to hide and be invisible to pings. The problem is there is. A lot of routers, a lot of modern systems now actually block ping because it is such an abused protocol. People have abused ping for years. Let me just do a search for ping security. Hold on. Security risk ping. Security risk of ping. Here you go. I've been told that ping actually presents a security risk, and it's a good idea to disable, block it on production web servers, yada yada yada. Yep, here you go. And to Angel Peach 424, here's your question. Here's the answer. Here's the really thing is a lot of modern operating systems actually now block ping, unless you specifically turn it on yourself. Also, a lot of routers actually disable it. Personally, I would not recommend letting any all ICMP pass for publicly visible servers. I believe you DDoS the ping service. We'll talk about that next week. You're all jumping the gun. Yes, ping can be used for distributed denial of service attack. Okay? Yes, ping can actually be used for a distributed denial of service attack, which will be next week. So there is a way to hide ping. I know that Mac OS, like if you go to your security settings, you can actually block ping requests. Yeah. Mm-hmm. Is who is IP address a good option for you? Absolutely, it is. So I want to get back to Nick Ricebowl's question. Who is IP address a good option for reconnaissance? It is. It is. It is. It is. It is. So what who is man who is an internet domain and network number directory service. Who is really is a gold mine for information. It will bring back addresses, physical phone numbers, system administrator contact information. List goes on. So if I know who is 35.226.223.155, you can see all the information that it got brought up back by who is. All right, this looks like it is a Google Cloud machine. Here it is. This is vital reconnaissance information. You have physical address, geolocate. Sometimes even you have geolocation. Sometime URL, telephone numbers. Yeah, absolutely. So who is a very good option for reconnaissance. Because it just returns so much valuable information, especially when it comes to addresses and contact information. So, okay, so we've seen who is, we've seen ping, we've seen the kill chain. The problem with just ping is ping will only show if a computer, remote computer, is up or down, is it running or not. That's it. But ping does not give any more information other than that. Does not give any information about things like, oh, what software target is running, what port numbers are open, what services are open on a target. That's the problem with ping. Ping is very limited. It's nice for diagnostics, just to see if a computer is running, but for more information, such as information that you really want, such as services that are running, software, even vulnerabilities, not available. So, okay, what other options do we have? So another option that we have is called, all right, I know everyone's looking for Nmap. I know that. Okay, I get it. Okay, but before I want to get to Nmap and to understand why we use the network mapper, let's use another tool. One of my absolute favorite tools is called the Swiss Army knife of the internet, a Swiss Army knife for networking, called Netcat. NC. Netcat. What Netcat is an arbitrary TCP and UDP connections for arbitrary TCP and UDP connections and listens. It is called a Swiss Army knife because it's a utility that can be used for just about anything under the sun involving TCP or UDP. It can open connection, close connection, send packet, you name it. The list goes on. And one of my favorite guides is the Netcat cheat sheet by the SANS Institute. Okay, who is actually will give a lot of contact information about a particular server or remote target. Dig. What Dig is? Dig is DNS, domain name lookup utility. So what Dig will do, it will actually give you if you enter in a domain name, it will return the IP addresses because every domain name must have associated IP information. So if I'm going to do dig github.com, you can see the IP address of github.com on my end. So also, by the way, dig is also a very valuable reconnaissance tool. You can actually see IP addresses as well too. NSLookup. What NSLookup is, queries internet names interactively. Look up information for a particular host. Yep, server. Oh, there it is. And let's look up dig and sometimes give back the same information. Okay, Netcat. I'm going to show you the Netcat cheat sheet. So Netcat cheat sheet is, okay, Netcat, what it does is, this Swiss Army knife, there's a whole bunch of things that you can do with Netcat. All you have to, the main fundamental level is NC, target IP address, and a port number. That's it. Now, let's say, for example, you're interested about port numbers. So if I actually want to see if the target that we're actually having question have an FTP server, which is at port 21, is NC 35.226.223.155.21. Okay, no information. Nothing. What about when it is 80? Okay, there's no information. You have to actually have some follow-up command. But there is on this cheat sheet here that says TCP port scanner. TCP port scanner. What it does is attempt to connect to each port in a range from end port to start port on IP address, target IP address. Run verbosely on Linux, yeah, or -VV on Windows, not resolving names without sending any data and waiting no more than 1 second. Okay, so this time let me use the cheat sheet and I do netcat -v -n -z -w1 35.226.223.155. I can do a range, but let me just do 80. Let's see what happens. Hey! Connection to port 80 seceded by way of netcat. Interesting. So that means that this target is running a web server at port 80, HTTP. What about port number 21? I thought it's supposed to quit after 1 second. Well, apparently not. If you're on a Linux machine, like pure Linux machine, you can actually do a start port like 10 to 1000. And you should actually see like a running list of connections. Okay? Let me actually clear the screen and SSH into my Pi hole. Let me see if I can do that. So if I try that on a pure Linux environment, it's slow. Oh my god, this is slow. Timeout, 21, 17, 18. Oh my god, this is so, oh my. Ooh, 22 is open, 23 times. Okay, I quit. I'm gonna clear the screen. Okay, so on a pure Linux system, you can actually do the start port and end port ranges. It's slow, but Netcat can do a lot of things, especially like making a connection to an IP address at a port number. All right, so we have seen ping. Ping is only going to show you if a target is up or down, or if a remote computer is up or down. You've seen Netcat, but Netcat seems like to be a slow option. It will actually, what Netcat will do is just say, oh, you know what, this port number and IP address is up. But that's it. Not very elaborate. But we want to see a lot more than that. We want something that is also fast as well, too. And that is where I want to introduce you to arguably one of my most favorite tools of them all, the network mapper. The network mapper, Nmap. Is there anything, one of my most favorite tools with also along with Wireshark. Nmap. The network mapper was written by my friend Gordon Leon. Fyodor. The network mapper. I want to introduce you to one of the quintessential tools in cybersecurity, which is the network mapper. Go to the official website, is nmap.org. The network mapper, or Nmap. Okay. The Network Mapper is a free and open source utility for network discovery and security auditing. Okay? Many system administrators and network administrators also find it useful for tasks such as network inventory, managing service upgrades, schedules, and monitoring host or service uptime. Nmap is really nice. It's really well built, fast, and tons of options. Nmap is also very famous in the movies. Yeah, Nmap has been featured in 12 movies, but one of my favorite examples, Nmap was in Matrix Reloaded. Was used in the Matrix Reloaded. Yep. It's also used in Ocean 8, Snowden, Dread, Asylum, Fantastic Four, Who Am I, Born Ultimatum. Okay, Nmap has lots of options, lots of really cool options. One caveat is that Nmap can be used for good and bad. So I know that system administrators love to use Nmap. So I know at companies, you can run Nmap on your whole corporate network, and you can actually see anyone who's running like a web server or like back in the days like a file sharing service. That stuff is important. Um, Nmap is extremely valuable when it comes to information gathering, when it's to gather information about a host or a target. So, how does Nmap actually work? There is free and open source. There is a front end that you can download for Windows for it. I always use the command line version of Nmap. So how Nmap is, I'm going to do, you have to install it. You typically on most systems, you have to install it on your own. You have to install Nmap on your own. It's not pre-built in. I mean, as good of a tool it is, it's one of those tools that you have to install on your own. On Mac OS, it's just brew install Nmap. If you're using homebrew. Okay, so install. Nmap. Nmap, the network exploration tool and security/port scanner. Okay. Nmap uses raw IP packets in novel ways to determine what hosts are available on a network and what services, including application name and service application name and version, those hosts are offering. You can even get information about what operating system that the target system is running, what kind of packet filters or firewalls are in use, and other really important other characteristics. Nmap is commonly used for security audits. Many system and network administrators find it useful for routine tasks such as network inventorying, managing service upgrades and schedules, and monitoring host or service uptime. Okay? So, how you use Nmap is there's a tons of different options. There's so many options for Nmap. There may be even examples on here. The online manual is fantastic, but at the most rudimentary level, how Nmap works is Nmap IP address. That's it. 35.226.223.155. Oh, important detail. Let's see what happens. It's gonna take some time. Now this is the most basic Nmap scan. Just Nmap, the IP address, and that's it. Come on. Everyone trying to hammer this damn thing? Hello? Hey, here we go. Here we go. We got the result back. Okay. So, here's your Nmap report, Nmap scan report for for the IP address 35.226.223.155. Let's see what we got. All right. The Nmap report results in the following: 1, 2, 3, 4 services. Port 22, TCP, open, SSH. That threat research. You did a good. Oh yeah. Hold on, I'll get to that question. Port 80, open, HTTP. Port 443, HTTPS. Port 3389, TCP is closed, MS-WBT server. Okay. So there are 1, 2, 3, 4 services listed. 3 of them are open, that means they're available, and 1 of them is closed, which is not available. So on this target at 35.226.223.155, there are 4 services. 3 of them are open, 1 of them is closed. We don't care so much about the closed one, but there are 3 services that are open. So what this means is this target is running an SSH server, an HTTP server, and an HTTPS server. Where? That true? Well, now you know that this target is running an HTTP server at port 80 and also HTTPS at 443. You can use your favorite browser, http:// type in the target IP address, and voila, you get a web page. There you go. This domain has been seized. I just pulled that picture from the web somewhere. HTTPS also should work. Ooh, connection not private. You ever type this? This is unsafe. Type that in, and then you get. So just type in "this is unsafe," all lowercase letters, all one word, and you get this. So you get the HTTPS site. You also know that this target is also running an SSH server. Let me see if there is on my course website under reading, is a cheat sheet for Nmap. Yeah. High on Coffee had a really good Nmap cheat sheet. Here you go. This is kind of old, so the threat research, this is a cheat sheet. For threat research, here it is. The guard port scanners used for network discovery and also for penetration testing. Yada yada. Try that cheat sheet. There's a whole bunch of things. Whole bunch. Okay. Also, now, okay, let's talk about what's going on. Let's talk about what's going on here. First of all, what is this state thing means? Let me actually bring up the port scanning basics. Let me bring up this manual. Okay. Port scanning basics. While Nmap has grown functionalities, let's begin as an efficient port scanner as remains in the core. Nmap, target scans, yada yada yada. So there are 6 port states recognized by Nmap. There's open state. An application is actively accepting TCP connection, UDP diagrams, or SCTP association for this port. Closed mean a closed port is accessible, but there is no application listening on it. So it's really nothing is working. So it's almost like an empty parking space. Filtered means Nmap cannot determine whether the port is open because packet filtering is preventing its probe from reaching the port. There's also unfiltered. The unfiltered means that they state the port is accessible, but Nmap is unable to determine whether it's open or closed. You have open slash filtered, which is, I don't know, Nmap places port in this state when it's unable to determine whether a port is open or filtered. Same, that's identical for close or filtered. Open is very straightforward. Close is pretty damn straightforward. That's what we got here. Open and close. Okay? Now, you may be wondering how Nmap actually works behind the scenes. Yeah, does filtered is good to see if your ISP is blocking services. We're going to see a filtered one hopefully in a bit soon. So, all right. So Nmap is nice because it brings back information about a target, all the services that are running. But didn't I say earlier that you can use Nmap to determine like what kind of operating system the target is running, what operating system the target is running, and other software versions. Okay, and yeah, you can do that. So I'm going to do man Nmap, and let's take a look at the manual. Here it is. Wait, here it is. It said the only argument used in this example are minus capital A to enable OS operating system and version detection, script scanning, and trace route. Minus T4 for faster execution, and then host name. Okay, not bad. There's another option that I like to use is a minus P0 protocol list IP protocol ping. Okay. Minus O, minus capital O enables OS detection. You can also have like firewall IDS evasion, spoofing, and all that stuff. We'll come back to a couple of these scan options. Okay, so if I do Nmap, now if I do Nmap minus capital A, that includes operating system and software detection, minus P0 at 35.226.223.155. This is going to take some time to do. So what hopefully we're going to see in a bit, you're going to see information about possible software version of the SSH server, software version that's being run by the web server, what operating system that the server or this target on Google is running. It's going to take some time. So while this is running, this is a good opportunity to really understand how Nmap really works under the hood. So far you've seen closed state, open state, filtered state. But what's really important next is the port scanning techniques. So port scanning techniques, I'm going to copy this. I'm going to post this in the chat. Nope, still running. Oh, wait, done. Here we go. Look at that. Here it is. This is the result of Nmap minus capital A minus P0 35.226.223.155. Now you see a lot more information other than port, state, service, and version. And now port, state, and service. You also see version. You can see the software version of OpenSSH that the target is using. You can see the web server software version that the server is using. In this case, the server is using Nginx. You can even see HTTPS certificate details. More goodness. This is based in Tennessee. And I want to give a shout out to my buddy Russell Butterini, TCS Hacksaw Tools in Tennessee. Operating system detection. Looks like it's a Linux kernel. Linux kernel. Just for your information about how services and software service detection is performed, it's done predictive. It's not entirely dead accurate sometimes, but it gives you enough information. So here is now Nmap with operating system and software detection version. You're going to see a lot more information than just port, state, service. But how does Nmap actually work under the hood? How Nmap actually works under the hood, let's read this paragraph on the port scanning techniques. The first paragraph is really important. If you're a novice, automotive repair, I struggle for hours trying to fit my rudimentary tools to the task at hand. Not every scan, Nmap has a lot of different scan types. Some scan types are more effective than others. Um, you can't just resort to one type of scan uh, for everything if you're trying to do reconnaissance by way of Nmap. Inexperienced users and script kiddies, on the other hand, try to solve every problem with the default sync scan. Aha, 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 aha. Hey, Encore, how are you? How are you, my friend? The legendary Encore. Encore the how. Looking forward to see you in person, my friend. Okay, inexperienced users and script kiddies try to solve every problem with the default sync scan, SYN. So now you know how Nmap works under the hood by default. It uses a sync scan. Does anyone remember the TCP Three-Way Handshake? Now you actually need to understand why. Now you're going to see why the TCP Three-Way Handshake is extremely, extremely important. A script kiddie is a derogatory term in cybersecurity for an inexperienced user. They just use the tools that is to create damage, but they have no idea how the tool was made. They don't know anything. They just run a bunch of tools and that's it. Okay, thank bye. That's a script kiddie. A script kiddie is someone who is they just use the tool as is. They have no idea how it works under the tools. Okay? And that's not good. Because the best security practitioners are the ones that actually use the tool, but they have an idea of how things work under the hood. Don't be like, there's a lot of hackers, a lot of computer security folks, there's a lot of people who actually use cybersecurity tools, but they don't even know anything about the network. They don't know anything about programming. They don't know anything about bits, bytes, and all that stuff. Okay, so underneath the hood, by default, sync scan by default is the default and most popular scan option for good reason. It can be performed quickly, scanning thousands of ports per second on a fast network not hampered by a restrictive firewall. It is also relatively unobtrusive and stealthy, since it never completes the TCP connection. So it never completes the sync, ACK, and ACK. Only SYN. So, but here is how it really, really works. SyncScan works against any compliant TCP stack rather than depending on idiosyncrasies of specific platforms such as Fin, No, Xmas, Christmas tree scan. We'll get to that in a few minutes. Very important. And idle scans do. This technique is often referred to as half-open scanning, since you don't open a full TCP connection, which is sync, ACK, and ACK. You send a sync packet, as you were going to open up a real connection and then wait for a response. If a sync ACK if the target responds with sync ACK, indicates that the port is listening. While RST, a reset, is indicative of a non-listener. Keep that in mind. A RST reset is indicative of a non-listener. Keep that in mind. So you may be wondering, someone may be asking yourself, can a target know if someone is trying to scan them? And the answer is absolutely. Yep. If a target is recording like network traffic, which most modern, like a lot of like public domain system, like corporate systems do, what they will do, what a lot of systems out there will do is they say, okay, yeah, this is a person trying to scan. Also, just vocabulary-wise, this is also known as scanning. Reconnaissance is, using Nmap is sometimes called using an Nmap scan. Okay. So now you actually understand why the TCP three-way handshake is important. But you know that people can be, the target may be recording what's going on. So can you get caught with an Nmap scan? Possibly, but then again, everyone scans everything all the time. But what happened if you want to be a little bit more stealthy? What happened if you don't want to be noisy? What happened if you just don't want to use a sync scan? You want to go a little bit under the radar. You want to be a little bit more what they call stealthy. And I want to introduce to you 3 scans in Nmap that can help you accomplish that. They're not as straightforward as a TCP, the default sync scan, but they may give you information back. Here it is. I want to introduce to you to my favorite types of TCP stealthy scans. And they're called TCP No, Fin, and Christmas tree scans. Now remember in the documentation above, it says while a RST being sent back to you, an RST packet being sent back by the target means a non-listener. What's the loophole? The loophole is this. If you're asking if a target has port, I don't know, let's say 21 open, and the target doesn't have port 21 available, what the target will say, okay, I know you're trying to touch FTP, but get out of here, RST. Okay? Now, hey, target, you got port 111 available on your target? Okay. No, get out of here, RST. Hey, target, do you have port 80 available on your system? Target doesn't respond with anything. So you can actually may infer there's something going on. It may be open. It may be open. That's what these stealthy scans do. They take advantage of a loophole, a subtle loophole in the TCP request for comment to differentiate between open and closed ports. Page 65 of the request for comment 793 say that if the destination port, this is the quote, if the destination port state is closed, an incoming segment not containing a RST causes a RST to be sent in the response. Then the next page is discuss packets sent to open port without sync RST or ACK bits, saying that you're unlikely to get here, but if you do, drop the segment and return. So it says any packet not containing SYN, RST, or ACK bits will result in a return RSTs if the port is closed, and no response at all if the port is open. So therefore, we want to craft, if you're an attacker, if you're trying to gather information, maybe we don't want to use sync at all. We don't want to use SYN. We don't want to use RST. We don't want to use ACK at all. What if we use the other TCP bits, such as FIN, PSH, and URG? So Nmap has 3 different scan types. The first one is called the no scan. What the no scan will do, it will actually send packets without any TCP flags against the target. The fin scan will only actually send packets to the target with a fin flag. Christmas tree scan, it sends a packet with fin push and urge flags, lighting the packet up like a Christmas tree. Also important that these 3 scan types, you have to be root, you have to be a super user to do. Fin push and urgent. Okay? The key advantage to these scans is that they can sneak through non-stateful firewalls and packet filtering routers. Another advantage is that these scan types are a little bit more stealthier. Even here it is, this one is these scan types are a little bit more stealthier than even a sync scan. Don't count on it though. Most modern internet intrusion detection system can be now configured to detect them. Okay. So how do you actually do this? How do you actually do one of these stealthy scans? The first thing is you have to do a sudo nmap minus lowercase s capital F for a fin scan. So I'm going to use the target 35.226.223.155. This may not work. 35.226.223.155. It may not work. But that's okay. I got another target to use. Looks like the system is doing something with it. Got nothing back. I can do the same fin scan against a target that is on my network at home. 192.168.1.10. See what happens. Ooh. This system actually on my home network at port 22, 53, 80, 443, 8200 open. And you can see the state is open/filtered. What about, I'm going to clear the screen now. No scan, 192.168.1.10. Oop. You're requesting a scan type which requires root privileges, so you have to type in sudo. Same thing. 22, 53, 80, 443, 8200 ports. All open. This is using the no scan. And last but not least, my absolute favorite is a Christmas tree scan. Same result. Not bad. So this is attacking a system that's on my home network at home. Not bad. Okay. This is nice. But now you know that these stealthy scans require you to be root. But how do these look under the hood? What if you are the administrator of the computer and you actually did record all the packets? Can you actually detect if someone is scanning you? And the answer is yes. What I want to do now is I want to open up Wireshark. And I want to show you how one of these stealthy scans look under the hood. And I want to let's take a look at this one. This PCAP from a fin scan. I have a fin scan here. Here it is. The source is 192.168.1.218. And the destination is 192.168.1.215. Okay? So here you can see 192.168.1.218 is trying to ask if 192.168.1.215 at port 199 available. The response is RST, get out of here. I don't got 199 open. Okay. 192.168.1.218 to 192.168.1.215. Hey, port 3389, are you open? Here you go, the next packet. No, get out of here, RST. Hey, 192.168.1.215 at 1723 port open. You can see the packet FIN. Nah, get out of here, RST. Now, let's go all the way down here. Hey, Target 192.168.1.215. Port 80 open. No response. You can assume that port 80 is open. Hey, what about port 80? There's no RST, so you can make an assumption that probably open or filtered. Hey, port 8080, are you open? Nah, get out of here, RST. Hey, port 8888, are you open? Nah, get out of here. Hey, port 22, are you open? No RST. Why are you seeing the RST response? Because the RST response is being sent to me from the target to me. And if you read the documentation correctly, it said it right here. Where was it? See the documentation. Any packet not containing sync RST or ACK bit will result in a return RST if the port is closed and no response at all if the port is open. It's in the manual. But now the question is, why do they require root on the attacking side? Yeah, I definitely have seen it before. Why is it root? There it is. Most of the scan types are only available to privileged users. This is because they send and receive raw packets which require root access on Unix systems. There you go. That's your answer. Good question. Requiring root privileges was a serious limitation when Nmap was released in 1997, as most users only had shared shell accounts. Now the world is different. Are there reasons why a machine might be not RFC compliant and might? Yeah, I mean, I know that people who actually write their own TCP stack. I think that's one thing that comes to mind immediately. Also, you have legacy systems. That's another thing that comes to mind. That's another thing. All right. I want to close the fin scan. I want to open up a Christmas tree scan. Actually, no, I can do a no scan. I can see a no scan. No scan. There you go. No scan, very similar. But no scan send packets with no TCP flag set. And you can see it by none, 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 none. You see an RST back, that means the port is closed. There you go. Port 80 is open because there's no RST sent back. What about the Christmas tree Xmas scan? One of my absolute favorite. There you go. Christmas tree scan. There you go. Hey, 192.168.1.215. Fin, push, urge. Hey, port 22, are you open? No RST. I mean, you can assume that it's open. Hey, port 111 at 192.168.1.215. Fin, push, urge. Is that open? Get out of here. You got a response saying RST. Get out of here. Okay? So, the problem is with the stealthy scan, yeah, I mean, they're kind of idiosyncrasy scans. And it says in the documentation here, they're kind of sneaky. Most modern IDS intrusion detection products can configure to detect them. So in my security class for the fourth lab, students actually have to build an intrusion detection product or script, really using SCAPI, we'll talk about that next Thursday, to detect no scan, fin scan, and Christmas tree scans. So how you do that is straightforward. If you see a packet with no TCP flag set, no scan. If you see a packet with just a fin flag, fin bit set, fin scan. If you see a packet with fin, push, and urge flag set, Christmas tree scan. It's important to know if the port is open so you can go and access them. So if you see, okay, for example, on this system right here, 192.168.1.10, you can see the system as SSH open, HTTP web server open, HTTPS open, and something at 8200 and 53. So you can go access them directly. That's why. That's why it's important to know why ports are, which ports are open. Then if the port is open, that means the service is available on that computer. You can go attack them. Or just try to gain access. All right. I want to talk about one more scan. You may be wondering, is there a way? Okay, I get it. I saw the TCP, I saw the packets, I saw the fin, null, and Christmas tree scan packets. It's recording the IP address. So the target may actually have an idea who is attacking the system. Is there a way to even be more stealthier? Is there a way to actually really confuse the target on who the attack is coming from? And I want to introduce you to a scan, an Nmap. Where is it? I thought it was here. It is not here. Same document? All right. Nmap Decoy Scan. This one. Yada, 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 yada. Okay. Is there a way that you can confuse the target and you can actually really confuse the target on like where the attack is coming from? Is there an even better way to go under the radar? And the answer is, yeah, there is. I want to introduce to you to one of my favorite scans, which I'm not going to do. It's called a decoy scan. Decoy scan. Now, a decoy scan, think of it as like a shell game. Like, you played when you were a kid. Like, okay, which cup had the ball? Here's what a decoy scan is. A decoy scan is it's a minus capital D option followed by a whole bunch of IP addresses of decoys. So what a decoy scan is, it makes it look like which makes it appear to the remote host that the host that you specify as decoys are scanning the target to. Thus, they'll say, I see a whole bunch of traffic coming from a whole bunch of different places, decoys. But they won't know which IP was really, really hitting them and which were innocent decoys. Now, there's a caveat though. These decoys, or these IP addresses that you specify as decoys, must be live on the network. They must be up and running. That's a very, very, very critical caveat. The IP addresses that you specify as decoys must be up and running on the internet. The reason is because the target will try to communicate back to the target. Now, and there is a really important note here. Note that the host that you use as decoy should be up, or you may accidentally sync flood your target. Also, it will be pretty easy to determine which host is which host is scanning if only one is actually up on the network. You may actually want to use IP addresses instead of names, so the decoy network don't see you in the name server logs. Right now, random IP generation only supported in IPv4. Look, the important point is you don't want to take down your target. Your whole goal of reconnaissance is you want to gather as much information as possible. You don't want to kill the target. You don't want to bring it down. You want to use real decoy, real IP addresses. Because if you don't use real IP addresses and you're using like dead IP addresses and the target's just trying to say hello, 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 you'll just exhaust the target going down. Not a good thing. You don't want to kill a target. You don't want to bring down a target at all. coincidentally, this is where this is like the really hard end of today, because this transitions well into next Thursday when we're going to talk about things like sync flood and distributed denial of service attacks when you bring down something on a network. So next week is going to be distributed denial of service attacks. One more thing. The one last thing I want to mention today is, okay, you've seen ping and its limitation. You've seen Nmap, Netcat and its limitation. You've seen Nmap. And we've gone to Nmap, the default scan. We've seen stealthy scans. You've also seen now the decoy scan. There is one more tool I want to introduce to you, and it is dubbed as the world's most dangerous software engine. It's a search engine for everything. Shodan. Shodan.io. What Shodan is, you can actually see how much stuff is out there on the internet. So, and the one thing that you can do is this target on Shodan? Well, let's see. If I can do a search for 35.226.223.155. Ooh. Shodan, excuse me, may already have some information about a target. Google, region, city, ISP, open ports. 222 and 443 identified. Oh, it even showed last update time, September 19 of 2021. Open SSH server details, Nginx details. All the Nginx details, port 443 is open. So what you can do is, actually, if it's port 480 or 443, you may be actually just able to visit the website. And there you go. Pretty cool. You get a lot of details. Also, what's nice is you actually get a map of where the target may be geographically located on open maps. Shodan also have, if you log in to Shodan, you can see things like all the open databases out there, all the open Minecraft servers, all the open Minecraft servers, webcams that are available to the world, whole Internet of Things. Actually, if this is true, can I go to images.shodan.io? Oh, I have to log in. I have to log in for this one. And this is where you can actually see like all the open webcam Windows systems available. So Shodan is arguably, but they also say this is the world's most dangerous search engine because it exposes everything to the network. I use Shodan for years for intelligence gathering. If you are a student or you have a .edu email account, you can actually get a Shodan account for free. I think for life. And if you're like a freelancer, it's $59 a month. Okay? So, scanning, reconnaissance, information gathering. That's the gist of today. Next week, we're going to get into distributed denial of service, Python, and Scapy. So yeah, that's all I got for today. Yeah, why does Shodan, here's my question. The question is, why does Shodan not list the same ports that, it's sometimes not accurate. It's sometimes not accurate, or sometimes they just disregard it. So, Shodan may not be entirely accurate. I mean, it's just, good question. Maybe it just ignores some stuff. But I have seen cases where, some things are not entirely dead accurate. Other than that, it's pretty damn good. Do we need any stuff for next week? Yeah, if you got Python and Scapy, pip install Scapy. Oh God, yeah. What's the difference? What's the difference between? Oh yes, yeah. Okay, Netcat that's a great question. What's the difference between SOCAT and Netcat? Netcat opens up TCP UDP connection. Do I have it on my machine? And SoCat. I don't have it. Hey, Uncle. SoCat, what it does is bidirectional. Wait a minute. SoCat versus Netcat. Yeah, they're both cat tools. Here it is. What's the difference between SoCat and Netcat? I use SoCat because, okay, SoCat can do serial stuff, Netcat can't. SoCat can do fairly advanced functionality like having multiple clients listening on a port or reusing connections. Yep. So HD Gant, if you run Netcat as a server, which you can, if you run Netcat as a server, so okay, HD Gant, if you run Netcat as a server, which you can only have one person connecting to you at one time. You SoCat, you can have multiple. Why did you ask? Why did you ask? Did you find out something? It's a good question. No, I'm asking. It's a good question. It's a real good one. That's the documentation for Scapy if you need it. I want you to hold on to the slot on SoCat. Yes, I do use SoCat. Not just, I use both Netcat and SoCat, but SoCat actually is great. If you're trying to create a server, you can have like hundreds and hundreds of people connecting at one time. That'll be next week. All right. I think we got a good one today. So we did Ping, Netcat, Nmap, of course. A little bit of Showdown. And even Stealthy Scan, Decoy Scans. And we're out of time. So yeah.